This is going to be, hi guys, thank you for joining me to this class. Today we want to talk about roots and rational exponent. However, I want to go over some concept that I really need you to understand and be aware of. So when we are talking about roots, we are used to have the square root of a number. So, and we know what does that mean. So, but I want to talk about the parts of the square, and I needed to identify this. So take a look here. We have a square root. We have root of 36 and root of 36. So what is inside, guys, of the radical symbol? This number is called radicand. Okay, that is the most important thing, radicand. Okay, we know that what is inside of the square, inside of this symbol, is called the radicand. This symbol is called the radical. This is called the radical symbol. And can someone help me? How do we call these little numbers, right? Here. Okay, this is called the index. I repeated what is inside of the radical symbol. This is a radical symbol. It's called the radicand, radicando. This symbol, the green one, is called the radical symbol. And the little number here, guys, similar to the exponent, in this case, it's called index because we're talking about roots. So this is the index. So usually, guys, when we don't have this number, this we assume this is 2, it's a square, right? So, and what is the idea of the, we're going to start off with the square root. Take a look, guys, at the similarities between root and exponent, which are like the opposite operation. So we're going to go over that. Just copy. Let's have a look at this one. We're asked to find what is the square root of 36. The idea, guys, again, in this case, we have the radical symbol here. This is called the radical symbol. We have the radicand. 36 is the radicand. And what is the index? Can someone help me? What is the value for the index in this case? What is this number if we don't have it?
2.
Correct. That is correct. This index is going to be 2 since we don't have it. Okay? Have that in mind. Okay, the idea here, guys, this is the first example. I know you can do it mentally, guys. But the idea here, guys, is to find a number that you multiply according to this index. Okay, the index is 2. I'm going to put it 2. You need to find a number, guys. You need to find a number x that you multiply these times, 2 times, and you get what number? And you get the radicand, which is 36. So can someone tell me what is the number, guys, that you raise to the second power and you get 36? What is the number, guys?
6.
That you raise it to the second power and you get 36. Correct. This number x is 6. Why, guys? Because 6 times 6 is 36. Take a look, guys, that this is like the opposite operation. It's like the inverse operation of exponent. We are using exponents. Take a look. We're using exponent in order to get the roots of this number. So, but guys, Mister, do I have to do exactly what you did in every single step? No, that's not necessary. I'm just showing you guys that is the main idea here. So, but you can say, guys, what number do you multiply twice by itself? By itself. Be careful. And you get 36. So you may say, Mister, I know that the number is 6. Okay, and this is the square root of 36. That is 6. Let's go look at a new one. What is the square root of 100? So, Mister, I don't see the index here. So if you don't see it, you assume it's going to be 2 squared. So you need to find what number you raise to the second power. You raise to the second power and you get 100. What is the number?
10.
That's easy, right? It's 10. 10. Why 10? Why? because 10 raised to the second power is 100. So actually, guys, we're dealing with exponent. That's what I wanted to point it out in this section. Let's go look at this one. What is the square root of 81? What number you raise to the second power and you get 81?
9.
9, and that is easy. Why 9? Because 9 times 9 two times is 81. Okay, or 9 squared is 81. So easy, right? I wish everything was like this in life. Now we come across with this one. What is the square root of 32? So help me. You can find a number that you multiply twice by itself and you get 32. So 1 times 1 is 1, 2 times 2 is 4, 3 and 3 is 9, 4 and 4 is 16, 5 and 5 is 25. We're getting closer. 6 and 6 is 36. So we just have a huge jump. We just step up. So it looks like there is no number, guys. You multiply twice and you get 32. However, what do we do in this case? Can someone remind me? If this is not a perfect square root, it's not perfect because you can't find a number, but you can simplify through a process called Oscar, the prime factorization. And this is exactly what we're going to use. We're going to use the prime factorization in any case, guys, that this number is either really big or it's not a perfect square. If this number is really big and you can find it, you can break it down and you will find it. Or in case it is not perfect. So let's have a look at this 32. Since it's not perfect, we want to break it down. Okay, let's break it down. 32. So you're going to help me. We're going to start off using special numbers. Those numbers are 2, 3, 5, 7, and in some cases we can get to 11 and 13, which is not, I mean, likely to happen. So, but we should have them on mind. So we're going to use 2, 3, 5, and 7. So we're going to start off by using the 2. Okay, 2. Can someone tell me what is the half of 32?
16.
16. Or in other words, what number do you multiply and get 16 and get 32? 16. And then take a look. This is an even number again. You use 16. What is the half of 16 again? 8, right? What is the half of 8?
4.
That's right. And take a look. That is an even number again. What is the half of 4?
2.
2. And what is the half of 2 again?
1.
1. And when you get 1, guys, that's your goal. So you have made it. So now we need to, guys, the idea, guys, is we're going to use it properly so we can cancel here. So take a look here that I have a score. This index, guys, is going to tell you how many groups, I mean, how many members are you going to include in each group? In this case, it's 2. Okay, that means you're going to make group of 2. So one group here, because I have two twos, they have this to be the same, in another group here. And this, guys, is going to be left over. So it's a lot, guys, like you and me. No one wants to be with us. So now, guys, instead of having 2, guys, how can I represent this 2 as a exponent? 2 square, that's perfect. 2 square. Okay, take a look. 2 times 2 is 4. 2 square is 4. Because this is factoring, actually, guys. It's representing 32 as a multiplication. 2 times 2 is 4. Times 2, 8. Times 2, 16. Times 16 times 2, 32. Okay, we're factoring this. So in 2 again, guys, instead of having 2, guys, we're going to say 2 square. And this 2 is going to be alone. Okay, just alone like that. Now we're going to rewrite this expression. So we have square root of 32. Instead of this, we're going to copy this factor form. 2 square, okay, the first part is 2 square, 2 square, and then times what?
2 square.
2 square again, okay, 2 square again, and then the leftover part is square root of 2, okay, times 2. Okay, just times 2, okay? That is what we have to do, times 2. Okay, now we try to simplify. So we know what property that you handle, right? If you have something with the same index, this little number, and the same exponent, what is going to happen, guys? If you have
We will
something like
We
this,
can cancel.
We will cancel it.
okay, excellent. If you have something like this, x raised to the mth power, and the index is m, so it's like you can cancel it. It's not like you can cancel. It's a property that is just going to be the same. X is going to be alone. So we're going to take advantage of this property right here. So take a look here. You have 2 square root. So guys, it's the same. So it's like you can cancel this. You can take the 2 out. Okay, it's just 2 without nothing. Take a look. The x is just bare here. So this 2 square and square root again, you can cancel it again. So it's going to be out as well, times 2. And can I cancel this, guys? This is 1 and this is a square root of 2. No, please don't do that. So that's going to be square root of 2. If you want to put the index here, 2 is okay. Okay, square root of 2, because this is first power and this is square, we can cancel it. Okay, I just copy. I can't simplify. So 2, guys, again, is not the best way to represent your answer. So 2 times 2, I know this is 4. And then I just copy this square root of 2. And this is, how do we simplify it? Square root of 32 is equivalent to 4 square root of 2. So take a look, it's not a perfect square. However, I did simplify it. Let's go look at more examples like this. All right, let's have a look at square root of 48. Again, if you don't see this number, the index here, if you don't see the index, you know it's going to automatically be 2. Okay, now let's see what number you multiply 2 times and you get 48. So I know you have tried and that's not possible. This isn't a perfect square root. So what I'm going to do, guys, since I don't have a number that I multiply twice and get 48, so I'm going to break it down. So let's break 48 down. So 48 is equal. So I'm going to break it down using the prime factorization. 2 times can I get 48?
24.
24.
24. 2 times again can I get 24?
12.
12.
Thank you very much. And then 2, 1 second here, 12. Okay. And then 2 times can I get 12?
6.
6.
6, thank you. 2 times can I get 6?
3.
3.
2 times can I get 3? That's not possible. Okay, we use 3 now. Okay, yeah, it's like a generator here, guys. We're using those numbers. So to generate what we have, 3 times can I get 3?
1.
1. And when we get a 1 here, guys, it means we have finished, meaning that we can move on. So now we're going to make group of what? 2, 2. Okay, let's make group of 2. This and this, this and this. So 2, 2. Okay. Instead of having 2, 2, guys, you're going to say, Mister, I know that that can be written as 2 squared. 2, 2 again can be written as 2 squared. And 3 is alone. So let's make this over. So instead of 48, guys, the factor for 48 is 2 squared. Okay, let's put 2 squared. And what is the next one?
2 square.
2 square.
2 squared times 3. Okay, 2 squared times 3 times 2 squared times 3. Okay, times 3. Okay, we just put this. This is a square root. So now, guys, a property. How am I the property? Because that is the idea. That is the main goal. We use the prime factorization because we need to cancel out something here. So you have 2 squared, a square root of 2. That's going to be just the 2, right? It's like you can cancel the square, the exponent and index, 2. And then 2 square and square. So it's going to be just 2 again. So it's like we cancel this exponent because we have the same index. And the square root of 3 is going to be inside. Okay, square root of 3. And we have finished. However, we need this expression to be simplified. 2 times 2, guys, is going to be 4. Square root of 3. Okay. And that is the simplified form of square root of 48. Okay. Excellent. Someone you just spelled events. So we have a square root of negative 49. So again, the idea, guys, here is to find a number that you multiply, you raise it to the second power, or you multiply it twice, meaning the same, and you get 49. Okay, let's have a look at that number. So someone said that the number could be 7, right? 7 times 7, and I need to get what? Negative 49. Negative 49. Okay, can someone help me? Take a look. 7 times 7 is 49, but I have to use the same sign, guys. Positive 7 and positive 7 is going to be positive 49. And I'm not looking for positive 49. I'm looking for a
So
negative.
be negative 7.
Could be
Okay.
negative, Mr.
Let's put negative and negative. So negative 7 times negative 7, 7 and 7 is 49. Negative and negative is going to be positive. What's going on here?
One negative 7 and one positive 7.
We can do that. If you're going to use positive, both have to be positive. If you're going to be using negative, both has to be negative. So which sign do I use? It looks like, guys, either I use positive. Take a look. I'm using the negative. Negative and negative, I am going to get positive. If I use positive and positive, I'm still going to get positive. That means, guys, that every single square, guys, that you use at the end has to be positive. And in this case, this is negative. So we don't have, like, when we were in 7th grade, we say, oh, we don't have solution for this. But you know that using the complex number, this is going to be, what is the square root of 49?
7.
7. And what is the square root of this negative one here? So what is the square root of this negative one here? I, right? So that's why we use complex numbers to solve this negative square root, guys. I just want my goal here, guys. I want you to notice that a square root of negative numbers involve complex numbers. So it's like we don't have real solutions for them. We don't have real solutions. So, but I'm gonna give you this. I'm gonna ask you this. Can someone tell me what is the cube root? Because when we have 3 is cube root of negative 8. So, and this is going to be your homework. What is the cube root of negative 8? Does it involve the complex numbers, imaginary unit I, or no? You got to
Yes.
answer that question eventually.
Finish.